All right, go ahead and hit record, please.
I got it. It's already recording.
Is it already recording?
Yeah.
Okay. All right.
Green.
Should have figured. All right, so lesson 37 has two parts to it. The first part is chemical compounds. What's water?
H2O.
H2O.
But pretty much everybody, even if they haven't taken a chemistry course, usually knows this one. All right, what does that mean? What does H2O mean? Yeah.
That there's 2 hydrogen and 1 oxygen.
Yeah. That means that we have a hydrogen atom and a hydrogen atom and an oxygen atom, and if we put them together, we make one water molecule. Now, what you may or may not be aware of is that different atoms have different atomic weight.
What?
Right? On the periodic table, there's numbers associated with them. For purposes of this class, we're rounding each atom's weight mass to a whole number. So even though the mass of hydrogen is like 1.0 something something, for purposes of this being a math class, not a science class, we're just going to say that hydrogen atom has a mass of 1, and oxygen has a mass of 16 instead of 16 point whatever it is in real life. So that means that a water molecule has a total molecular weight of 18.
18 what?
Grams, or the gram atomic weight. Which means that we can say, if we can make ratios with that. Let's take a look at example 37.1. The chemical formula for water, H2O. If we have 3,600 grams of water, what's the weight of the oxygen? All right, if we have 3,600 grams of water, what's the oxygen? Well, we can do the ratio of oxygen to water. What is that ratio? What's the ratio of oxygen to water?
2 to 1.
No. The ratio of hydrogen atoms to oxygen atoms in the water molecule is 2 to 1. However, we're talking about, the question is asking about
116. 16
grams. What?
1 gram to 16 grams.
Each
to
oxygen atom has a gram atomic weight of 16 grams. What is the atomic weight of a water molecule?
18. 16 to 18.
Because it's one oxygen, which is 36, and 2 hydrogens that are 1 each.
Geez, that's a lot of
Right?
units.
So when we're talking about water and the ratio of oxygen in water to water, the ratio is 16 to 18. And the problem says that we have 3,600 grams of water, and what's the mass of the oxygen? So here's our ratio, cross multiply, and divide, and you're going to get 3,200 grams. You used the calculator, didn't you?
It's so easy. You don't even really need to do it.
I know, 18 goes into 36 twice with 2 more zeros, that's 200 times 16 is 3,200.
Yeah, you don't really need to even.
That's right, you don't even really need to use a calculator a whole lot.
You don't need to do the cross multiply and all that stuff.
Nice try. All right, a couple more examples here. 37.2. So that's the basic idea. You got to figure out what the gram atomic or gram molecular weight is, and you find that by adding up the total mass of each of the atoms that are in it.
So we will now be using our periodic tables for math?
No,
No, you don't
it
have
tells you.
Oh,
All
it
right,
does.
chemical formula for ammonia is NH3.
Stop.
Ammonia is NH3, which means that that's 1 nitrogen atom and 3 hydrogen that are combined to make 1 molecule. If we have 510 grams of ammonia, how much does the nitrogen weigh? And nitrogen has a weight of 14, hydrogen has a weight of 1. And the problem will always tell you what the weight of each atom is. All right, so we're looking for the ratio of nitrogen to ammonia. 1 nitrogen is 14, ammonia is NH3, so that's 1 of these plus 3 of these, that's a total of 17. The problem says that we got 510 grams of ammonia, and we want to solve for the nitrogen. So here's our problem to solve. Yeah.
Mind if I, like, zoom in a little bit so you can see what you're doing?
Okay. Either way. Yeah.
It's 420.
Yes.
Yeah, just too much.
Grams. Don't forget your units.
Don't worry, I never forget my gram.
All right.
Kind of weird.
I never forget gram.
One more example. All right. One more example real quick. So we've got ammonium chloride, which is NH4Cl. And this is example 37.3. And it says, let's see, how many grams of chlorine are there? So we're looking for the ratio of chlorine to this molecule, NH4Cl. Nitrogen is a weight of 14, hydrogen is 1, and chlorine is 35, and the problem tells you that. So chlorine is 35, 1 nitrogen plus 4 hydrogens plus 1 chlorine, that's 35, plus 14 is 49, plus 4 more of these is 53. So the ratio of chlorine to ammonium chloride is 35 to 53. And the problem says that there's 100, asks about, it wants to know how much chlorine in 1060 grams of ammonium chloride. So there's our proportion problem, cross multiply, divide, and don't forget the units. And that's how to do those chemical composition problems.
Yay.
Stop the video.